Alexa, stop. All right, so this is section 13.1. So this is the area between curves. So we're going to continue adding layers onto finding definite integrals. So this is just a visual of why we subtract the high from the low. So this first graph is showing the f function. So remember, with integration, antiderivative, finding the integral, what we're doing is we're finding the area beneath the curve, all right? So when I have this f function, it's the green one, if I'm going between a and b, I get this whole area, all right? Now, if I'm going to subtract off the g function, so the g function is below the f function, it's still in between a and b, so you can see when you have this whole amount and you subtract off the lower amount, what you end up with is the area between the two curves. So this is just a visual of what we're going to be doing. The key to this is to make sure that you subtract off the upper curve and subtract off the lower curve. So the upper curve minus the lower curve gives you the area between the two curves. All right, so that's the premise behind what we're doing when we're finding the definite integral between two, or the area between two curves. So let me give you an example. So this is where you can use the website desmos.com. If you don't have a graphing calculator, it allows you to plug in the two functions, and then it will show you the two graphs, and then you can kind of see. So let me do this on the whiteboard, and then I'm going to show you on Desmos what I'm talking about. All right, so we have two functions, and I'm going to do this in two different colors so that you can see the difference between the two. So our f function is x plus 3. So if you are good at graphing and you just want to do a sketch of the graph, you are more than welcome to do that instead of using a graphing calculator or Desmos.com. So this, you know, is a line. I know it's a linear equation because I have x to the first power and I have my y value. I also know that it crosses at the y value of 3. So there's my 3. My slope is 1, which means I go up 1 and over 1, up 1 and over 1. So there is my f function. Okay, so now I'm going to do a g function. So the g function, I'm going to do this in green and I hope it shows up, is x squared plus 1. So the g function is a parabola. I know that because it's x to the second power. I also know it's my parabola lifted up by 1. So I know that it's going to cross when x is 0. My parabola is going to cross at 1. And I know that when I put in 1 here, 1 squared is 1. So when x is 1, y is 2. If I plug in negative 1 in here, negative 1 times negative 1 is 1 plus 1. So when I have negative 1, I also get 2. So my parabola is going to look something like this. So notice it's a sketch. The only purpose of this is to identify which is your upper function and which is your lower function. So the question is, determine the area between the two curves on the given closed interval. So the other information that you're going to be given is the endpoints. So I want to find the area between the two curves between negative 1 and 2. So here's negative 1. Here's 2, okay? So I am looking for the area between the two curves between negative 1 and 2. So this is the area that I'm looking for, that shaded region between those two curves. Well, my linear function is on top. My parabola is on the bottom. So when you're finding area between two curves, remember you're subtracting the upper minus the lower. So your antiderivative is going to look like this. It's between negative 1 and 2, upper value on top, lower value on the bottom. And I am going to subtract my two functions. So this is my f function minus my g function in terms of x. Okay, so here's my definite integral. the upper function minus the lower function evaluated between -1 and 2. And that's going to give me the area between the two curves. So now I'm just going to simplify. Don't forget this negative needs to get pushed through both. So it's x plus 3 minus x squared minus 1. So I have a definite integral between -1 and 2, not 3, where it's, and I'm just going to rewrite it in descending order, negative x squared plus x, and then 3 minus 1 is 2. So there is my definite integral. And now it's right back to 12.5. I got to sneeze. Bless me. Did you notice the elbow thing? Okay, so now I'm going to find I have my definite integral. There is my antiderivative, and I'm going to find the derivative. I'm sorry, I'm going to find the original function. So here we go. We're going to add one, divide by the new exponent. I'm going to add one, divide by the new exponent. And then this one, I'm going to add 1. So plus 2x. And now I am evaluating it between -1 and 2. Okay? So some of these can kind of get long, and there's a lot of process to it. But if you're just organized and stay focused, you can do this. All right, so here is my integral. Here are the values that I'm going to evaluate. So I'm going to go ahead and rewrite this. And notice x squared over 2 is the same as 1/2 x squared. So if you like it better in this format, then go ahead and change it. And now I'm just going to evaluate. So I have -1/3 times 2 cubed plus 1/2 times 2 squared plus 2 times 2. So that is my first value. And then I'm going to subtract off -1/3 times -1 cubed, I'm going to run out of room, plus 1/2 times -1 squared, plus 2 times -1. Okay? So I'm going to erase, I'm going to erase up here so that I can continue. Man, I wished I had a bigger whiteboard. All right, so now I'm going to get all of these values. So to save some time, okay, I'm just going to do it because some of you are going to go, how did you get those numbers? All right, so here we go. 2 cubed is 8. So in my first set, I have -1/3 times 8 plus 1/2. 2 squared is 4 plus 4, 2 times 2. So that is in my first set of brackets. So I like to just continue with the same thing, and then I'll jump over to the second set. If you want to get this and then come over here and do this and kind of work back and forth, you could do it that way. I just like to stay consistent, and I just stay within this first bracket. So -1/3 times 8. So remember how to multiply fractions. -1/3 times 8 is a -8/3. Half of 4 is 2 plus 4. So still within my first bracket. So here's where you can use your calculator because we are looking for an actual value. So -8 divided by 3 is -2.666 plus 2 plus 4. So I get 3.333. Yeah, 3.333 in the first set of brackets. And now I have that answer. So now I'm going to come over here. So I'm subtracting off. So here we go. -1 cubed is -1. So I have -1/3 times -1 plus -1 squared is 1 times 1/2 is 1/2. And 2 times -1 is a -2. Still minus sign on the outside. So -1/3 times a -1 is a +1/3 plus 1/2 minus 2. So now you can go to your calculator. 1/3 plus 1/2 minus 2 is a negative 1.1666. I want to make sure I have my negatives all there. Okay, and now I have minus a negative. So again, you have to make sure that this minus sign keeps being brought down. Whatever's inside your bracket is, whether it's positive or negative, you still have to adjust that. So it's 3.33 plus 1.1666, and I get 4.4966. So that is the area under the curve, about 4.5. Okay? So lots of calculations going, but it's just numbers. You guys are like numbers, apparently better than variables. So whenever you're finding area between two curves, get the upper curve, subtract off the lower curve, and then plug in your values. All right, now I'm going to show you real quick over here on, if you can see it, my computer cooperates. So this is, I'm going to move you around so you can see what I'm looking at. Let me get my chairs out of the way. So let's see how this shows up, if it shows up. Oh, not bad. Let's see if I can take it down a little bit. Don't get sick. Okay, so there is my calculator. So what I'm going to do is I'm going to plug in these two functions. So the first function, so what you do is once you have it, you're going to come over here and you're just going to type in the function. So you can see the red line is my, and you can move it. You can put your cursor on the screen and just move it so that you have the values. So this is my x plus 3 function, and then you come down to the second line, and I'm going to put in my second function. So there's my g function. Okay, so it looks very similar to what we just did. And then here is my negative 1 is here, and here is my 2 is right here. So we are looking for the area between this value right here and this value right here. Now there is a way, I don't want to show you that yet. There is a way to do this with Desmos where it shows the area, and I'll show a different video on that. But anyway, you can get an idea. So here you know that the f function is above the g function, so you are going to do f minus g and then apply the evaluation points. All right?